Hey guys, welcome back. Here we are talking about JNCIA-Junos again. And if we get back over here to the blueprint, I've blown up the first section, Junos Operating Systems Fundamentals. We will try to go over some of these first things about identifying concepts, benefits, functionality of the core elements of the Junos operating system. Junos seems to me like a put together phrase of Juniper OS. Anyway, we'll try to cover some of these things right here: software architecture, control and forwarding planes, the RE and the PFE, the routing engine and the packet forwarding engine to start with. Then I might cover those later, these other two bullets. Okay, so right away you are going to be needing to get on the command line of a Juniper router in order to explore some of the things that we talk about. And as you study for the JNCIA-Junos exam, you're going to need to get on a router. Here's a few different ways to do that. You can explore Juniper Virtual Labs. These are two links that take you to about the same place. What is Juniper Virtual Labs? Well, let me paste this into here. Juniper Virtual Labs is a service that Juniper provides. It has preset topologies for routing, switching, and security, and it gives you a chance to try out Juniper technologies. It's free to the public. That's a big one right there. I would also mention that when you get into Juniper Virtual Labs, you will need to create a sign-on, a login account. And when you do that, one of the things you're presented with, I'm sorry, this is a little bit blurry, but whenever you fill in your personal information, you'll need to choose one of these options. If you don't have any authorization code or serial numbers for products, then choose one of these last options here, lab user for access to VLabs right here, or guest user access. I think you want to try this second to the last one. And then it will send you an email later on granting you access. Okay. Another thing that I would like to show you real quick is a little more about virtual labs. It tells you here some of the operating systems and platforms that you'll be able to work with. Juniper has a few main platforms, the MX, the SRX, the QFX, and so they have virtualized their software. They put that little V in front of it, meaning that it runs in a virtual environment. And so they actually have performance-based virtual software for actually using in performance in high-performing networks. But then you also have a trial version of these as well that you can use for labs. Okay, here's some of the preset topologies that VLabs has to offer, and here's a video that you can watch about VLabs as well. Now, another way to interact with the Junos operating system and to create yourself a lab is using EVE-NG, that is Emulated Virtual Environment Next Generation. There's a free community version of EVE-NG that you can use and install on a computer or a high-powered server if you have access to one. I have access to EVE-NG, and I'll also provide a link that talks a little bit about how I've set up an EVE-NG environment for Juniper as well as Cisco. So here's a link right here for Juniper and Cisco labs and how to set it up in EVE-NG. I'll provide this in the comments so that you can easily access that video. And here is my EVE-NG instance of Virtual MX. Now, when you look at that video that I previously spoke about how to add VMX into EVE-NG, you add two nodes. I talk about that in that previous video, the control plane and the forwarding plane. and you connect them together with the EM1 interfaces. What these are is the virtual control plane and the virtual forwarding plane. So a Juniper MX router is clearly separated into two different planes. The control plane is the routing engine. The forwarding plane is made up of line cards. Okay, it's kind of the brains and the brawn, so to speak, of the MX router. Okay, and so even in software, even in the virtual MX software, Juniper mimics that by creating a virtual control plane and a virtual forwarding plane. So that's what I'm showing here with a couple annotations and a line to separate that. I put a box around both the virtual control plane and the virtual forwarding plane to show you that these are, in fact, these do make up the overall router. This is what an MX router looks like. So that's why I labeled it like this. And these two nodes, that as you add them into EVE-NG, comprise of the totality of an MX router. All right? So it's very nice that you interact with it in this separated fashion in the EVE-NG virtual lab. Hey, I want to talk a little bit about the Junos software architecture. So as you know, the MX router is separated into two planes, a control plane and a forwarding plane. The forwarding plane is otherwise known as the data plane. So this is the brains, so to speak. This is the brawn. I like to put it like that. The brawn is like the muscle of the router, the actual packets per second, how much we can put through this router. So the brains is the RE, otherwise known as the routing engine. The brawn is the packet forwarding engine. The packet forwarding engine is made up of all your line cards. All right. The routing engine is the processor. The CPU are the multiple CPUs that are implemented in the routing engine control plane. CP, FP. Okay, and the Junos software runs up here. The Junos kernel. Okay, and the Junos kernel is based on FreeBSD Unix operating system. Okay, there's a microkernel that is put down into the packet forwarding engine plane, the forwarding plane. There's a microkernel of Junos that's pushed in to the line cards. Okay, the control plane runs a lot of the routing protocols, also management, also interfacing with the router SSH. Like I said, management protocols like SNMP. A lot of those things are run in the routing engine. All right, and again, down here is where your line cards are and your interfaces. If they are separated into various line cards, you have cables coming out of them. That's where all that is taking place as well. Okay, so when you connect, I say connect, when you interact from the command line using a console in EVE-NG, what you're going to do is you will click on the control plane icon here. So you click on this, and you are interacting with the router at the control plane. Okay, you're not going to click on this forwarding plane. If I do this, you'll see that it's some kind of low-level Wind River Linux operating system. I have rarely ever, I can't even remember ever needing to do something from the command line for the virtual forwarding plane. Okay, so don't mess with that unless you really need to. Again, you'll click on the control plane. Now I will say this, if later on we're going to connect another router to this one, and when we connect those routers using virtual network cables, you connect those to the virtual forwarding plane. Okay? So that's where you'll make those connections between routers, is on the forwarding plane, which totally makes sense because that's how you connect routers together, through the forwarding plane. All right. So let's move on. Now when you log into the router, use the word root by default, and it takes you to this prompt here that looks like this. This is not where you want to be when you interact with the router. This is a low-level shell, and you don't want to mess around in there unless you really need to. Okay, to get to the actual router CLI, you do just that. Type CLI. It stands for Command Line Interface. Hit Enter, and you see how the prompt changes to a greater than sign. It actually shows you the username that you're logged in as, root. Okay. Now I want to show you this before we get too much further. Actually on the, you know what, this thing is giving us these messages, and I want to talk about that briefly. The virtual MX, or actually a MX router, comes factory defaulted with an auto image upgrade function turned on, and the FXP0 out-of-band management interface is trying to DHCP an IP address. So let's get rid of both of these so that we can stop these messages. All right, I'm going to turn those off, but then I'll explain a little bit more about configuration in a little while. Okay, I turned off those messages, and I'm going to put at the end of the video exactly how I did that so you can stay well informed. But I wanted you to see, when you first log into a router, you see its mention of FreeBSD. I'll talk in a little while about the fact that that's what Juniper operating system is based on. And you have this word amnesiac. The router has amnesia, like it forgot everything, which basically means it doesn't have a configuration, it doesn't have a host name. So if we go in here, go to CLI, here's how you configure the router. Configure, and you now have a prompt that is a pound sign. Okay, the way that we configure a host name is set system hostname. You always use the word set when you're configuring. Okay, so you use the word set. If you hit question mark, here's all the possibilities of things under the word set. You can set access profile, set accounting options, set bridge domains, set chassis, set system, way down here. So that's how you configure the host name, set system. If you hit question mark there, you can see all of the things that are possible under set system. Okay? One of those things is set system hostname. It's right there. All right, hit question mark, and it basically says, hey, put in a host name for this router. All right, so we will call this VMX1. All right, now the way that you see your pending change is show pipe compare. The plus sign shows that this is the configuration that's going to be going into effect. Now, why hasn't the prompt changed to show this host name yet? Well, Juniper-Junos, as well as Cisco's iOS XR operating system, are both very service provider centric, and they have a lot of things that are different than classic iOS or Cisco iOS XE, where if you type a command in classic iOS of Cisco or iOS XE, the command takes effect immediately. Not in Cisco iOS XR and not in Juniper Junos. Okay, so you have a concept of a candidate configuration, and we'll talk a little bit more about that later, but you're altering the candidate configuration right now. And show pipe compare shows you that this is a pending change. Okay, now if you were to exit out right now, it tells you that the configuration has been changed, but it's not been committed. Do you really want to exit with an uncommitted change? Yes or no? And it gives you a default answer. If you hit the enter key, this default answer will take effect, which means you're exiting out without committing the change. Okay, but we're going to say no. And so we're going to commit the change. Now, in order to commit a change, you type the word commit. Now, there is a way to execute a dry run to to check the sanity of a configuration. So if you do commit check, it will tell you, it tells you that you're missing a mandatory statement. Now you can't make configuration changes as far as the host name and various other items without setting a root password. So set system root authentication plain text password. So we will call the root password ROOT 123. Oh, excuse me. That's not where you set it. Hit the enter key, then it prompts you for the password ROOT 123. Retype it ROOT 12. Okay, and you have now implemented the root password. Show pipe compare shows you that you have two pending changes, the host name as well as root authentication. And it also encrypts the password as secret data. So now we can do a commit check. The sanity of the configuration is good. And if it wasn't, it would tell you that there was an error. And so now we will commit the change. Now we see that the prompt now shows the user that you're logged in with and the new host name of the router, VMX1. Okay, if you were to exit out, now it no longer says amnesiac. It actually says the host name of the router. All right, so this is just basic login of Junos and initial configuration. Another good thing about the separation of the Juniper router architecture is that something adverse doesn't affect the other, or system enhancements of one or upgrades of one doesn't necessarily have to include the other either. Now, for the routing engine and the packet forwarding engine to communicate, there's something known as an internal link that connects these two together, and that's how they communicate, okay? There's a policing that happens across this so that exception traffic doesn't inundate the routing engine and adversely affect the control plane of the router. Transit traffic would be unicast traffic that's going across the router, or that's going across the forwarding plane, all right? So coming in one interface, going out another interface, this is transit traffic, okay? Traffic that's destined to the router itself or that needs special handling like an ICMP reply. This type of traffic would be known as exception traffic that would go up to the routing engine and then would require some kind of a reply from the routing engine. All right, that would be exception traffic. The routing engine is usually based on an x86 chipset. The packet forwarding engine is based on what Juniper is quite proud of, their Trio chipset. So an ASIC, application-specific integrated circuit, known as the Trio chipset, is what the packet forwarding engine is typically based on. And so that you are aware, I will show you exactly what I did to disable this auto image upgrade and DHCP function that's taking place on the out-of-band management port. So we went into config mode and we do exactly what it's telling us to. Delete chassis. We just copy that command and we commit that command. Okay? And so those messages will stop. As far as the FXP0 port goes, let's show that interface. And I'm going to delete that DHCP function also. All right. So I'll put this at the end of the video. So at least you know how I accomplished that. Hey, I hope that was helpful. Just a brief introduction to the JNCIA. It gets us going in the right direction. a little bit about how you might access the command line interface. Want to add also, you might be able to pick up a very inexpensive, relatively speaking, Juniper device on eBay.com. You might hunt around for one there, find one used, and a little SRX. SRX, we'll talk about some of the platforms of Juniper later. I made mention of it earlier, but the SRX platform is their firewall family of products. You can get a really small SRX that's pretty capable as a lab device, and that will give you something to interact with. I think there's a 200 series, it's one of the older ones. The SRX 300 series is one of the newer, very small ones. I think 300 is the smallest, and then they go up from there, like the 320, the 340 or something like that, the 345. But look at the SRX 200 series or the SRX 300. You can put those routers into, you can put those SRX firewalls into router mode so they act like a Juniper router. All right. And so look into that. That's another option you have. And so, hey, we're on our way with going over the JNCIA. So I hope this was helpful. Subscribe and like it, and turn on the notifications if you want to get future notifications of the next video that I'll be posting.